Let's go to the call delta and the put delta, and by definition the call delta is just the CDF of D1, so this is what we get for the call delta. It's the CDF of D1, and I just wanted to round the result 2 points after the decimal point, and for the put delta you can see that it is the CDF of D1 minus 1. This is the delta for put option, and this is what I wrote here. It's the CDF of D1 minus D1, and again I rounded it so it will be easier to see and read. And of course you can see all this formula in my website, ALON/SELA.com. Now let's go to the gamma. So for the gamma expression, let's see the formula. The formula, as you might know, the gamma for call and the gamma for put is the same, and this is the formula. So I'll go back to the first line that I told you I will explain later, and later is now. So this is the line that we're going to use, and you can see it here. We have e to the minus half d1 square, so e to the minus half d1 square, and we need to divide it by the square root of 2 pi, so we divided it by the square root of 2 pi. So this is this expression, and for the gamma we did this expression, and now we need to multiply it by this expression. So let's go to the gamma. So you can see this is the first for the call gamma. This first bit is this, as we just saw, and we need to multiply it, or we need to divide all of this by this part. So we have the spot time the volatility time the square root of the days to maturity. So this is this part, and here I put I wanted to see 4 digits after the point, and so I rounded it to 4. And as we just saw, the gamma for put is the same for gamma for call, and this is why the put gamma is just the call gamma. Now basically the other Greeks are built just the same way, the same method. I took the formulas. You can see all the formulas in my website, and just follow the formulas and write it in the Python code. And I want to show you one live example. So I left the row for the put for us to do together, so let's do it together now. And just before we are doing the row for the put together, I want to see that if I'll calculate the values now, you can see that the put has basically nothing, and later on we're going to fix it. Okay, so this is the formula for the row of a put option, and I just enter it here. Okay, I just enter it here for us to see and get a reference. So you can see that this is a minus k times the time to maturity times the exponential of minus r times the time to maturity and times the CDF of minus d2. So this is the expression that we need to enter here. Okay, so let's see how we can write it. So we need the strike, so we'll have self dot strike and times the days to maturity, self time days, and we'll need to multiply it by the exponential of minus the rate, so self dot rate, and times the days to maturity, so times self dot days, and all of these need to be multiplied by the cumulative distribution function, so times stats norm dot CDF of self dot minus d2, and I guess I just made a little mistake because I need to put the minus here, and now we have the row for put option, and